Hi, this is Mark Zamoyda. This is the first video on ARM assembly language using ARM's tools itself. So the first thing we should go over is how to set up these tools. It's pretty straightforward. I'm running Parallels here, so let me just go into Windows mode full screen. The website you need to go to is keil.com. So we'll go keil.com. And let's see, go to software downloads and product downloads. And in order to write assembly language for the ARM processors, you need this MDK ARM, this toolkit right here. You go into that and there's a form you can fill out, and it's pretty straightforward to install it. It's about half a gig, and download it and install it. Here we have it running here. It's called Keil MuVision 4. I'll start that up. And yeah, you definitely want to make it full screen. And it starts with a sample project. We can just go to Project, Close Project, and start from scratch. We'll go to Project, New MuVision Project. And let's just call it First ASM Project. One that was recommended to me, like to select a device here, was NXP, let's see, 20 LPC 2104. So we'll just grab that device. Copy startup.s to project folder and add to project file. We don't need that, no. Okay, so now we have a project and our source files go in here. So let's add a new file and save it, and let's just call it, well, let's create a folder. First ASM, I'll just put it in there. Call it first ASM.s. Remember to put the .s because that's an assembly file. So we have it over here, but notice that it's not in our project. Let's make sure it's saved and right click and add files to group. And make sure we have our .s files. And we clicked add, and that added it. We can't look at it, but it did add it, and we can close this out. And yep, there it is right there. Okay. So I'm going to pause this and enter some code. Okay, so I entered some code here in our first ASM file, .s. Make sure it saves. And before we walk through this, let's just make sure it builds. We'll hit the build button over here. If we look down here, we see 0 errors and 1 warning. I'm not exactly sure what that warning's for, but it's fine as long as there's no errors. And once we have it built okay, we can debug it with the start stop debug session up here. This is an evaluation copy, and the code limit is 32K, so that'll be fine for us. And here is our debugger. Let me just organize this a little bit so it stays somewhat sane. All right, we're good to go. So I'm going to stop the debugger by pressing that again, and let's take a look at our source code. So this is our first assembler program, and basically there are two different aspects to writing assembly code. One is giving commands to the assembler itself. These do not get executed by the microprocessor, they get executed by the assembler when it assembles the code. So here we just have a name for this whole section and an area. It's like an area of code or an area of data. Here we specify that the area is code and it's read-only, like we don't want to overwrite our own code. And entry is the beginning of our assembly code, and end is the end of our code. So everything in between is basically assembly code that gets executed. If something, normally you put labels on the left side, so reset handler would be a label and stop would be a label. Those aren't executed by the CPU, but those are referred to. If we look at this program in particular, it's very simple. The first command that's going to execute is called move. And what move does is it will move this number 11, which is decimal. If it were hex, it would be, 0xOB or something like that. But it's 11 decimal into a register called R0. Now, I haven't gone over registers yet, but that's really easy to understand once you see it in the debugger. So after it moves 11, you can think of a register as a variable, like a local variable, something like that. So we're putting the number 11 into register 0 here, and then the next step means branch, and which is like it's going to jump to some other area. And where's it going to branch to? It's going to branch to this label called stop, which is right here. So basically this is an infinite loop that is just going to continue to run over and over and over. And the good thing about that and why we end it that way is because we can examine the state of the microprocessor, like any registers or flags, and it'll still be an active session. Okay, so let me just save it, make sure it's good, and you got to remember to build it before you debug it. So it's built. We have our 0 errors down here. We'll hit the start stop debug session. And here we go. For now, I guess we can look at this window down here. The yellow arrow points to the next line that's going to execute. That, I guess it's cyan type color, points to wherever the whatever command you're on, the cursor's on. So this is our source code view down here. Up above that we have, let me scroll all the way up here. Oh, okay, it doesn't have all the source code, it just has, the command up here. So here's our move command, and the line under it, it's pretty cryptic, but let's just go through it while we're here. This first number is the memory address. So the memory address is 0. That's fine, we start off at 0, and each one just increments by, it looks like 4 bytes, which is a word which is 32 bits, because this is ARM processors are 32-bit processors. So you can see the memory location on the far left here. The next set of numbers are the actual bits that are in that memory location. And this is cryptic, and you're not expected to understand this. So that's why the debugger puts the move statement. And it's specifically, we're going to move this hexadecimal number B, which is decimal 11, into the R0 register. So let's take a look at what a register is. A register is a super high speed area to store information. If we look on the left here, you can see all the registers are 0, 1, 2, 3, all the way up to 12. We can use registers 0 through 12. And registers 13, 14, and 15, they have special names, SP, LR, and PC. We'll get to those in other videos. But for now, you can just know that we have these high-speed storage areas, which are 32 bits long, 4 bytes. And we can use R0 through R12. And we can store information in there. So what I want to do is I'll step over this move statement. We'll go to step one, or step over here, one line. And you can see that two things lit up in blue over here on the left. Well, first of all, we went to the next instruction. It did successfully execute that and went to the next line. But the changes over here occurred in blue. And the first change is where R0 was 0 before, now it's B, hexadecimal for 11. So that worked. We took the value B and we put it in register 0, and yes, register 0 does have a B in it now. So we know that command worked. The other thing that happened was register 15, which is our PC stands for program counter, changed to tell us what line we're on. Now we're on line, or memory address 4, and that's correct, we're on memory address 4 here. Now if we continue to step, we're just going to be stuck in that infinite loop. And we have B in our R0 register right here, and we are stuck in an infinite loop, and we have 4 stuck in our R15 register, no matter how many times we step over it. And that's fine. That's our first assembly program.